Hey everybody, how's it going? How's everyone's December going? I'm Dr. Ventures, meteorologist for the weather company. I just want to be clear. The purpose of this stream here is not to reflect the views of my employer, but to just kind of nerd out, talk about some interesting science things that are going on, and just to be passionate about the weather, because that's why we're all here. That's why we care about these things. We love what's going on. So thanks so much for joining in the stream, everyone. For everyone who's new to Twitch, if you want to ask any questions or participate in the chat, you just need to follow me on Twitch to get access to that. And from there, that's pretty much it. I'm going to focus on a number of topics today. We're going to talk about the stratospheric warming. So a lot of buzz going on in the Twitter sphere about stratosphere and what that means for winter 2021. And we're going to talk about some ENSO. We're going to talk about El Nino, La Nina, what's going on in the tropics. Because that's where my background is. I'm like a tropical meteorologist by trade, but my passion is starting to shift to the stratosphere because there's a lot of interesting things that happen in the stratosphere that we don't fully understand. So you know what? I'm going to start it off here, guys. I see everyone joining in on the chat here. So let's move on with the discussion. I hope everyone's having a good holiday season, by the way, guys. I know it's been a rough year. 2020 is nearly ending. I thank God it's been one of those years that I'm ready to move on from. I hope everyone's been healthy. I hope everyone's had a great holiday season. And here's to 2021. Let's move forward here and look at the future rather than focus on the past. And that's what I plan on here doing on what's happening right now in the weather. So let's get into it, guys. We are talking stratosphere. So there is an event underway right now, and it's what's called a sudden stratospheric warming event. It's essentially when you look up way up into the stratosphere, above the troposphere where weather occurs, and we see a lot of variability during the winter season, where times where we have a very strong stratospheric polar vortex, and there's times where there's a weak polar vortex. These times where there's a weak polar vortex is where we get these things called sudden stratospheric warming events. And we're seeing one right now starting to pop up over Siberia. And you can actually see it on this image on the left here, essentially where we have this big bullseye of anomalous warmth. When I say warmth, guys, we're talking minus 20 C. So that is cold, cold, cold up in the stratosphere. But still, it's nowhere as cold as if you sit underneath the stratosphere polar vortex, where we're like talking about like minus 80 C. But anyway, we're seeing this bubble of warmth start to emerge over Eurasia. And, we can actually see some hints of a stratospheric ridge developing over the North Pacific and parts of eastern Siberia there. And here's our polar vortex. Nice little bullseye, a lot of cold air underneath Greenland here. But what's happening over Siberia is essentially this initiation of a sudden stratospheric warming event that will eventually begin to nudge the polar vortex off of the North Pole. Now, we call these types of nudging events a stratospheric displacement event, where essentially it's exactly what it sounds like. Your stratosphere polar vortex wants to sit over the North Pole, but when the atmosphere forces it to move away from the North Pole, we call it a displacement. And you can actually look at the 10 millibar temperature anomaly field here. We got plenty of anomalous warm air over 20 degrees C beginning to build across much of Eurasia here. And we're going to watch that eventually push the polar vortex off the North Pole and displace it towards the North Atlantic, North America, and parts of Europe there. So for those who are new to the stratosphere and what these types of things are, here's some basic illustration of our atmosphere. So here's the Earth, right? And here's the troposphere. Troposphere is the coolest place in the world, in my opinion, because it's where weather occurs. But you get a lot of other things in there. That's where we fly pretty much. But if you get above the troposphere now, that's where we get into the stratosphere. So essentially, the stratosphere is the layer above the troposphere, and it's below the mesosphere and thermosphere, essentially where we typically see asteroids burn up, and our polar orbiting satellites. And then as you get further up into the atmosphere, you get into the thermosphere and the exonosphere. So I am focusing on a warming event right in the stratosphere here. And essentially, this is a connection here with where, the stratospheric warming event will have a connection with weather, where troposphere is, right, in the troposphere. So let's take a look at some of the models here and look at some of the forecasts. So I'm going to back this up. we're looking at the ECMWF ensemble, and we're looking at 10 millibar temperature anomalies in the shading. Wherever you see like the warmer colored shadings, like the yellows and the reds and the browns and the pinks, that is where essentially we're seeing this anomalous heating in the stratosphere at 10 millibars. And wherever you see the blues and purples, you can think of that as anomalous cooling. And right now we're watching this big area of anomalous warming focused over Siberia. The polar vortex, indicated by these contours here, is located right over the eastern part of North Pole, right north of Greenland, or to the northeast of Greenland there, north of Eurasia, Siberia. And watch this now as I loop this forecast forward here. This is the ECMWF ensemble mean. And just watch how that area of anomalous warmth begins to push away from Eurasia and out towards the North Pole. And as it does so, we're going to watch this, essentially this big ridge in the stratosphere begin to pretty much settle over the North Pole, or at least part of the North Pole here. And this is what we call a sudden stratospheric warming event that is initiated over Siberia. And I'll get to that, what that means, where it's beginning. This warming pulse is beginning over Siberia, but it can happen actually over other parts of the globe as well. And these are still things that we still don't really understand. A lot of folks that I've talked to in the community who've really focused on, understanding these sudden stratospheric warming events, they haven't really looked at where the warming event initiates. They typically look at, the impacts and essentially when the warming is focused over the North Pole. So these are some things that I've been exploring throughout my career here at the Weather Company, trying to understand these things because I think they're really interesting. But let's move forward with the forecast here. Right now, this is essentially New Year's Day, and we're seeing this area of anomalous warmth begin to lift towards the North Pole here. We're talking about over 25 C above normal temperatures at 10 millibars. And as it pushed forward here with the forecast now, this is where essentially we're starting to see this stratospheric ridge at 10 millibars begin to nudge across the North Pole. And what this means is we're going to see a pretty significant change in circulation about the stratosphere North Pole. Whenever you get this ridge that settles across the North Pole here, instead of getting this anomalous westerly spinning about the North Pole, this changes the flow. This ridge will essentially change that westerly belt around the North Pole and actually start to change it to an easterly flow, which is by definition a major sudden stratospheric warming event that happens at 10 millibars. So as we move forward in the forecast, I want you to take a look at what the polar vortex does here as the warming really settles across the North Pole, the anomalous warm air, and that ridge starts to bulge in across the Pacific side of the North Pole here. We start to see this elongation of the stratospheric polar vortex, and actually you can actually see it here in the temperature anomalies, right? You can see this banana shape here in the colder than average temperature anomalies at 10 millibars. This stratospheric polar vortex is getting elongated, and it's no longer this perfect vortex that just sits over the North Pole and spins. This is a displacement event, folks, and that's what we talk about these when I was mentioning, getting pushed off the North Pole. This is essentially the stratospheric ridge pushing that stratospheric polar vortex off the North Pole and elongating it into this like banana shaped feature. So remember, guys, we're looking at 10 millibars. We're essentially taking one little layer of the stratosphere and doing a cross section. We're actually not really seeing enough information here to understand exactly how the polar vortex is being modified by this warming event and that ridge settling over the North Pole. So one area that I typically like to look at is a three-dimensional cross-section that is done by what was a grad student at University of Albany. This is Zach Lawrence, and he has these really awesome three-dimensional cross-sections or schematics, of the stratospheric polar vortex. And that's essentially these yellow contours here. This is essentially, you can think of it as like a skeleton map of the stratosphere polar vortex in a cross-section view where you're looking at essentially you can move up into the atmosphere, and this is height here. So at each one of these horizontal lines, that's essentially getting higher up into the stratosphere. And here's the surface of the Earth. You can see the nice little base map here. Here's North America, here's Greenland, here's Europe, etc. So here's the strat vortex today. And you can see it's not really healthy looking. There's a lot of different little orbits around it. It's kind of misformed a little bit. It's not a healthy looking polar vortex. And that's because of the current warming that's going on over Siberia. It's already doing some modification to the stratosphere polar vortex, kind of making it elongated. Now let's move forward in the forecast. We're going to go out to early January here and take a look at what's happening aloft around that 1200 isotherm here. Essentially, we're seeing the vortex, a tail of it starting to spin off here, and we typically see these tails, happen when we get a warming event that is initiated over Siberia. I've seen it a number of times since Zach put these posts up, since he started this product, and you can able to look at these stratosphere polar vortex in a three-dimensional sense. Whenever you get these Siberian warming events, you see this typical tail start to get peeled off all the way at the top of the analysis here. I'm assuming this is way up into the top of the stratosphere, above right around that 10 millibar level there, and you can really see that tail start to push off there. And this is a really typical signal of these Siberian-initiated sudden stratospheric warming events. Now, as we move forward in the forecast here, I'm going to change the view back. We can actually see the entire stratosphere start to get these like leg-like appearances, right? If you're thinking like, here's a human body, you start to have two legs start to pop out here. This is essentially, we're starting to see significant lower tropospheric forcing on the stratosphere polar vortex at the lower levels, and that's starting to cause the stratospheric polar vortex to begin to split. Now, as we move forward in the forecast here, that becomes more and more defined. And we're looking out now at around hour 348 of the GFS here. Take a look at hour 360. We're really starting to see two independent vortices begin to spit up. Now, they're still connected aloft, right? At 10 millibars, you still see them together there. But as you move this forecast out further and further in time, you can actually see how these things are starting to separate here. I'm just changing the views regionally so you can kind of get an idea and see the best view of this potential split of the polar vortex. So, guys, this is a very impactful thing, right? The stratosphere polar vortex last winter, if we talked about this last winter, it was one of the strongest polar vortices we've seen on record at times. It was just a remarkably strong vortex, and we didn't really see much in the sense of high latitude blocking last winter. It was a very mild winter across much of the northern hemisphere. So right now we're starting to see this happen, and it starts to give us a little hope for winter. We're starting to see essentially a sense of possibility here for some wintry weather for parts of the northern hemisphere. Now, where that wintry weather occurs and when it occurs is still uncertain. And that's because we still don't fully understand these type of splitting events. So I do want to say here that, for the North America, in order to get some really cold temperatures across North America, you really need to see a blocking high over the North Pacific. And that's essentially analogous to a weaker Pacific jet flow. Right now, we're not seeing that. And I'll get to that in a minute here. But I do feel, I have strong belief here that the reason why we haven't really seen that blocking high over the North Pacific is because the stratosphere polar vortex has been coupled. And there's like a filament of the stratosphere polar vortex has been pretty much persistent over the North Pacific for quite some time. And that has been there. And we see it in the GFS forecast just kind of stay there for a period of time. Even as this polar vortex begins to split, we still see a lobe over the stratosphere polar vortex over the North Pacific. And I think this is an indication here that if you really want some cold weather in North America, we need to see this feature move out of this part of the world. So that's just a hypothesis, guys. I'm again still learning about these stratosphere tropospheric connections. There's a lot of smart people on social media. I recommend following some of the experts here, which I can get to at the end here and talk about some folks to follow to really brush up here on some of these things. So there was some precursors in the atmosphere that could predict, that would suggest strongly we're going to see a significant displacement of the stratospheric polar vortex. And that's something that we can essentially derive through what's called a Siberian high and Aleutian low index, which I for short I call the SHAL index. And essentially, when the SHAL index, the Siberian high Aleutian low, is positive, it represents essentially a stronger than normal Siberian high pressure system over Siberia and a low pressure system that's strong over the Aleutian Islands over the North Pacific. When the index is negative, the opposite's true, right? Your Siberian high is very weak. Your Aleutian low is not really there. There's a ridge over the North Pacific, and this could be a very negative index. But when this index is positive, it essentially represents that there's going to be an upcoming period of forcing on the stratosphere polar vortex that will result in a displacement of the stratosphere polar vortex. And we've seen this index pretty much positive throughout much of the winter so far, right? November, we had a 2 standard deviation rise of this index into early December. And now we're looking at another rise of this index into 3.5 sigma over this past week and over the upcoming week. So this is a big signature in the atmosphere that's saying, hey, the atmosphere is going to force that stratosphere polar vortex off of the North Pole. And we're going to have some mischief here and some possible split potential moving forward. So, and that's what we're seeing here in the forecast. And there's a lot of really good stuff here you can look at in this particular the StratObserve page. We can actually look at a number of GFS ensemble members and take a look at how the GFS ensemble begins to evolve the stratosphere polar vortex in the forecast. Now the blue here is essentially your polar vortex. The red contours is essentially that ridge in the atmosphere that I was telling you was starting to like bulge or nudge in from the North Pacific. And as we move the forecast forward here into the extended range, we do start to see some GFS ensemble members begin to show this split in the vortex, right? You can see ensemble member 15, the GFS operational, ensemble members 17, 18 there. So there's some potential here, guys, for this split in the atmosphere. And another product that actually kind of really sums up the number of splits, if you look at a number of different models and put it on the same plane here, you can go out to this longer range forecast here, and actually 20 out of 74 ensemble members. Now we're talking about the GFS, the Canadian, and there's another model there. I think it's the FM model there, the FNMOC. Essentially, you look at all these ensemble members and count the numbers of members that are split. 20 out of 74 members split the polar vortex into sister vortices. So that's just under a third of members. So this is, if there wasn't any risk for this vortex to split, you would see 0. And we saw that all last winter. So now we're seeing 20 out of 74. So this is something robust here in these numerical weather prediction systems that are highlighting the risk for a possible sudden stratospheric warming event. If we look at the CFS V2, this is the American subseasonal model that will eventually be decommissioned here as the unified model moves online. But if we look at the CFS V2 here, we look at 50 millibar temperature anomalies, and we're essentially looking at observations in the green line here, outlined by like these green boxes. And the CFS V2 forecast appended onto it there with each member indicating a different line. Each line, there's like 4 different green lines, 4 different blue lines, 4 red, 4 pink. Those are different cycles of the current day here, or the current previous day of the CFS forecast. And you can see how all CFS V2 members bring up the temperature anomalies to 10 C average over the entire North Pole, 60 to 90 north. This is an indication, guys, again, in this model, I have seen it a number of times, that there's going to be a significant warming event at the 50 millibar level. So all the models, guys, are locked on here and are, highlighting some impactful forcing from the stratosphere on the troposphere. Now I want to go back to something here on Zach's page, and this is the Northern Annular Mode Index. And this is something that I like to look at a lot to understand what's going on in these troposphere-stratosphere connections. And back in November, we saw a lot of these like red shading pretty much in this image here. And, if I orient you guys here on your x-axis, this is time. So it starts in November 1st, goes out all the way to January 1st here with the forecast. And as you go on the y-axis, this is essentially your pressure in millibars or hectopascals. So you start at the surface at 1,000 millibars, and you go up into the stratosphere up to 1 millibar at the top here. And essentially when you see this big red signal shading feature here, this is essentially showing positive NAM or Northern Annular Mode anomalies. And this is an indication that the stratosphere polar vortex was quite strong back in November. And actually, how strong was it? I want to bring back something here. I'm actually showing my internal page here, and I want to show you November 500 millibar height pattern Here we go. For the northern hemisphere, let me zoom out a little bit here so you can kind of bear with me here. Okay, this was November. We're looking at 500 millibars G potential height anomalies, and you see a very strong positive NAM signature where you have big negative G potential height anomalies over the North Pole and Greenland, and a ring of positive heights around that, extending from North America and parts of Europe. And you can see a different view here from the Europe side of the view there. This is essentially a signature that the stratosphere polar vortex is strong, and we had this positive NAM feature in our atmosphere, which is analogous to what we see here from much of November. Now, as we move into December now, this is essentially where we're seeing things get interesting. We're no longer seeing these positive NAM anomalies. Instead, we're seeing these negative NAM anomalies. We're getting a lot more blue shading in the stratosphere and into the troposphere. That is analogous here to more of a blocked up high latitude pattern. So there's also some interesting things in here where essentially you guys can see like some negative NAM anomalies start at the surface right at the end of December and propagate poleward or propagate vertically into the stratosphere. There's some indications here that we had some kind of significant wave flux from the troposphere up into the stratosphere that has disrupted our stratosphere polar vortex, and now we're starting to see these negative NAM anomalies really get going at the top of the stratosphere and propagate down into the lower stratosphere with time. So the question is, will this make it all the way down to the into the troposphere and impact weather? And that's still to be seen here. But there's actually I'll show you some fun things here that really highlights that there is a coupling going on, and there's some real significant things going on there. So typically when we get these sudden stratosphere warming events over the North Pole, we see a deceleration of those westerly flow around the North Pole, which is pretty much the dynamics of the polar vortex. And you can really see that here in this image that's from Hannah Attard, a really good expert in the stratosphere, and she has a lot of really good things that are available for you guys to look at on our webpage. But I want to focus on what's happening in the forecast, right? So here's your November timeframe. The blue line shows what actually occurred, and whenever you're above this, essentially this black line, you're essentially saying your stratosphere polar vortex is stronger than normal. If you're below that black line, it's essentially saying your stratosphere polar vortex is weaker than normal. And we're looking at essentially zonal winds. Anything above this zero line, you can think of it as westerly winds. You can think of it as like westerly winds orbiting the stratosphere North Pole. And if you drop below that zero line, that is essentially where you're saying instead of having your westerly flow around the North Pole, it's actually going to be easterly flow, the exact opposite. And this is an indication here that the GFS forecast does drop the essentially winds into down into negative values, which is essentially saying, guys, this is a major sudden stratosphere warming event predicted by the GFS model during the first 2 weeks of January. And you can actually see the entire flow about the North Pole stratosphere shift from a westerly regime into an easterly regime. And we're actually, you look at the bottom of this gray shading here, that's a 2 standard deviation envelope. We're talking about a 2 sigma drop here in winds. So this is a very significant event when looking back into climatological values of our polar vortex. Now, if we were at the top of this gray peak here, that is essentially saying, hey, this is a very strong polar vortex, but now we're down at the bottom of the envelope, and just another diagnostic here to kind of confirm here that we're seeing the warming at the stratosphere. We're seeing the stratosphere polar vortex begin to split into 3-dimensional cross sections, and we're seeing the entire flow about the northern hemisphere reverse from a predominant westerly regime to a possible easterly regime. Now, again, these are still in the forecast mode, but we're getting to that point where it's impactful, guys. So one way to kind of look at a 3-dimensional cross section of temperature anomalies is through this product where I like to look at essentially pressure by time, and the shading represents temperature anomalies throughout all levels of the atmosphere. And here's our polar vortex back in November, very strong vortex signature by colder than average temperatures across much of the stratosphere down to the troposphere here in early December. But take a look at what's happening in the forecast mode with the appended 35-day GFS ensemble forecast mean. Thereafter, we see this big warming at the 10 millibars, and then we start to see that slowly propagate downward into the troposphere, into the top of into the bottom of the stratosphere and into the top of the troposphere. And you actually see some upward wave flux as well from the surface of the Earth towards the stratosphere. So that's interesting as well. There's some connection there as well. So guys, I really want to kind of talk about, these different areas of warming and what it means for weather impacts. And when I say warming, I'm talking about stratosphere warming events. And this is something that I actually gave a presentation on at AMS back in 2019. And I'll actually bring that presentation up here for you guys to take a look at because, again, I'm still learning a lot about these stratosphere polar vortex events. But I do want to again reiterate the fact that this warming event is beginning over Siberia. And I actually created a way to look at these different warming zones at 10 millibars through an EUF analysis. And you can see here the Siberian warming event, the Siberian box here is showing a 3 standard deviation warming event, which is corresponding to this big significant warming signature we're seeing here on the map to the left. Now, you look at the North Pole, the polar signal, we haven't really seen much of that signature yet in warming. That's going to change here the next 1 or 2 weeks. We're going to see that signal go really high here in this particular box here. But if you look at the Atlantic and North America, we see colder than average temperatures there. That's corresponding to the polar vortex kind of nudging there. So this is just a really simple way to kind of identify where warming is taking place. And, obviously you can use your eyes in this map and say, yeah, it's over Siberia. Why do I need this box? Well, the beauty of these boxes here is I can go back into our archives and see what happened during specific warming events, like over Siberia or over the Atlantic. And that's where we get into this PowerPoint presentation that I want to share with you guys. So if you guys bear with me here for a minute, I am going to change over our screen share to a PowerPoint. And we'll see if I can actually get it here. Let's see. There we go. All right, so this was the presentation that I presented at AMS January 7th, 2019. For those guys watching this and are meteorologists, it's sad that we won't see each other at AMS this year due to the COVID restrictions and ongoing pandemic, but I will be attending AMS virtually. For everyone who doesn't know what AMS is, it's essentially the American Meteorological Society annual conference. They put it on every winter where a bunch of meteorologists get together and present really interesting things on the weather. So it's it's something that is really awesome to attend, and it's really awesome to kind of go in and talk to some of these experts in the field here. So let me bring up what I want to show here and move on. Now, I was focusing this particular presentation on a sudden stratospheric warming event that happened in February 2018. And actually there was one later in December that really sparked my interest. And I'm going to actually skip a lot of this and get into into what I really wanted to focus on. And when I was looking at this particular pattern, February 2018, we had a very significant warming event that started over the North Atlantic and pushed into Greenland and over the North Pole. We didn't see the Siberian warming actually much that year. It didn't start there, but it did eventually made its way towards Siberia when the warming event was mature. This was a complete split of the stratosphere polar vortex during this event. Now, later on that year, in December 2018, we saw a significant Siberian warming event happen, where we had all the warm air start over Siberia and push its way over the North Pole, and then eventually get over the North Atlantic and split the vortex into, I think it was like maybe 3 sister vortices. And 2020, or 2021, I guess you could say, January 2021, when this event takes place, this is essentially the case that we're following here. These are the Siberian warming events. So I went back and went into these EUFs that I just showed you earlier on, the live data, and I wanted to see back in history what these events meant. Was a North Atlantic event important? Was a Siberian event important for weather? And when I meant weather, I'm talking about globally, right? North Atlantic, North Pacific, America, Europe, etc. So I was able to identify 2 EOFs that really captured the 2 types of warming zones that I wanted to really capture. One was this EUF2, which is Siberian warmings, and then the other was this EUF4, which was these North Atlantic warmings. EUF3 and EUF4. EUF3 has the Siberian warming, and EUF4 is the North Atlantic warming. And I went back into into our archives and just using a really crude analysis from NCEP NCAR reanalysis. And I looked at a lag composite analysis, and I really wanted to identify these significant sudden stratospheric warming events, like looking at 2 standard deviations and above to get those really big warming events over these parts of the world. And I did these composites to understand if there was any precursor signals to such warming events. On the left here are all of our North Atlantic warming events. On the right are all of our Siberian warming events. And if you look at the difference between the number of events here, the Siberian warming events, actually I was able to get 36 different events here where there was the Siberian warming event from stratosphere, really significant warming, 2 standard deviations or stronger. And the North Atlantic case ended up being about 23. So, a significant amount fewer. So when we talk about sudden stratospheric warming events, we typically see more events start over Siberia, but there are still a number of events that can start over the North Atlantic and split the vortex. And I also have all the years listed here if you want to take a look at these different events, when they took place, etc. But the real big interesting thing that I want to talk about is when we get these North Atlantic warming events. We're looking at 500 millibar G potential height anomalies here. 14 days prior to the sudden stratospheric warming event starting over the North Atlantic, we see this big anomalous ridge in the atmosphere over the North Pacific and into into Alaska, with a downstream trough over the Hudson Bay into Western North America, and a ridge over the southeastern U.S. This is very analogous to what we talk about, essentially like a La Nina pattern, right? A negative PNA, negative Pacific North American pattern, where you get a ridge, trough, ridge couplet over the North Pacific down into the southeastern U.S. Now, if we take a look at the Siberian cases now, it's the exact opposite. You get a trough over Alaska, and a ridge extends across North America into Greenland and into parts of Siberia, with a cutoff trough over the southeastern U.S. into parts of the subtropical Western Atlantic. So there's a difference here in these 500 millibar G potential height patterns leading up into our sudden stratospheric warming events, and they can dictate where these warming events take place. Now let's take a look at 7 days prior to the event. And if you look at these 2 different composites, it's pretty much a 180 degree out of phase relationship, right? These Siberian cases, you get this big Aleutian cyclone and a anomalous blocking feature over the Hudson Bay up into Greenland and over parts of Scandinavia into parts of Siberia. And it's the exact opposite for the North Atlantic cases, which is really interesting. Now, in February 2018, this is where we saw essentially a warming event start over the North Atlantic and propagate over Greenland that eventually and effectively split the stratosphere polar vortex into sister vortices. Now, if we look at the pattern that preceded that warming event up into the time, we saw this was the actual pattern that took place on the right, February 7th through February 13th, 2018, and we compare it to our North Atlantic composite, you actually see a very strong similarity here between the 2 cases, right? You get this big Alaskan ridge, pretty much a anomalous cyclone over the Hudson Bay into Greenland, and an amplified subtropical ridge over the Atlantic basin. So a very similar case, right? Now let's move forward and talk about the December 2018 case, where we saw the sudden stratospheric warming event start over Siberia, propagate over the North Pole, and split the vortex into sister vortices. Well, let's take a look at what happened in that pattern. Well, here's the December 10th to 20th of 2018, leading up to that sudden stratospheric warming event. You got this big Aleutian or Alaskan cyclone, a ridge that extends from North America up into Greenland, into Scandinavia there, and a ring of below normal heights from the southern tier of the U.S. and into like the northern Atlantic. Very similar to the composite, guys, in this Siberian warming case. Now I want to switch gears quickly and go back into our screen share for our Chrome forecast. So let me go to that quick. And I apologize for going slow here, but I think this is important to kind of go into here. Okay, here we go. So I want to take a look at a tweet that I did the other day here. I think this might have been yesterday or maybe the day before, 29th here. It was the 30th. This was yesterday. This was the Siberian composite, right? We just took a look at that. Take a look at the ECMWF ensemble forecast for the time this warming event is taking place. We have this big Alaskan cyclone and this ridge that extends from North America up into Greenland into Scandinavia and parts of Siberia. Very, very similar, case to the composite here. And this is just a Siberian stratospheric warming event that's, there's an atmospheric signature that goes along with these Siberian warming cases, and as well as there's one with the Atlantic cases as well. But I just wanted to highlight this is a Siberian case that's happening here in the forecast, and the atmosphere is behaving as we typically expect it to compared to these composites. So I just wanted to highlight that was an interesting thing there that kind of came out here. So I'm going to go back to our PowerPoint presentation because I want to talk about impacts, right? I want to talk about what happens now. How should we expect the atmosphere to behave? So let me bring that up here. Back to the PowerPoint. Okay, back to the PowerPoint here. Let's go down with the time here to the composites, and let's go to 7 days after our sudden stratospheric warming event in our archives. Well, one thing that's clear, we see a significant change in the pattern over the North Pacific. Now we're talking about winter in North America, and we want to see some cold air across North America, but we can't get it yet because we have this fire hose Pacific jet stream bringing in all this mild Pacific air across much of the North America, and it's cutting off our Arctic supply of air. Well, after our sudden stratospheric warming event, in the Siberian cases, we actually see a reversal in the pattern over the North Pacific, and Alaska, and the North Pole. We actually see that vortex, that big Alaskan cyclone breakdown, and we see this ridge start to develop over Alaska into North Pole. And if we move out forward 14 days after the event, you can see how that event really that ridge kind of sticks out there. But we get this now deep upper level low that digs across western half of North America. So if I were to say, guys, this is a rinse repeat, this is what's going to happen. If we're talking about this sudden stratospheric warming event, which should start to take place here in the next week or two, we're looking at maybe the second half of January, where we start to see a significant change in the North Pacific pattern that allows for some Arctic air to start to build over Western Canada and possibly bring some cold, significant cold fronts down across the heart of the nation, and maybe some more wintry conditions. So that is something that is still to be seen here, but it is interesting nevertheless, and we still see these periodic episodes of blocking over Greenland following our sudden stratospheric warming event. We're looking at 21 days after the Siberian warming event peaks, and we see here we still have this nice blocking signature across the North Atlantic, Greenland, and into parts of Europe there that allows for some wintry weather across the eastern seaboard. So these are composites. Every case is unique. It doesn't mean that this is going to be the lock-in, hey, this is the Bible, this is the truth. I don't know if it's going to happen, but it's something that encourages me at least to say, hey, there's some possibilities for a North Pacific change in the pattern that really impacts North American weather. And it gets us a little hopeful for some wintry weather across much of the North America, eastern two-thirds of the nation, including the Pacific Northwest. Now, if you're out in Europe and you're watching this stream, there are some interesting things here that I want to talk about in these composites. And, this is a little bit technical, so I apologize if I lose some folks here. But what I want to focus on here are, we're still looking at these composites, but in a different way now. We're essentially looking at a lag on the y-axis where time is going down, and your longitude's on the x-axis here. And if you have a hard time understanding where, we are in the world, if you're a meteorologist and you know what 60 degrees west means, well, there's a mini map underneath it here. So you can see, okay, 60 degrees west means there's Greenland there. So we're looking over Greenland, essentially, if you bring your eyes up over this part of the map here. And you can see that the same thing is true for the Siberian composites as well. What I want to focus on here are two things, right? Here's the precursor. Leading day zero is when the sudden stratospheric warming event is taking place. When you have that North Atlantic event, you typically see a big ridge preceding the North Atlantic warming events over the North Pacific, and that allows for these instantaneous and prolonged period of North Atlantic blocking, which is good for cold weather across the eastern U.S. as well as over Europe. But if you take a look at the Siberian warming cases, now this is important. I want to focus on this here. We have this big Aleutian cyclone. I just showed you the Eastern Lift Ensemble forecast of that cyclone, right? take a look at the North Pacific pattern. It changes, and it changes for a pretty significant period in time. You're looking 40 days after the warming event, and you still have elevated heights over Alaska and the North Pacific, which is good. We need to see that change. We need to see the Pacific Jet break down from a ridge developing over Alaska. But I want to focus on the North Atlantic side of the world for these Siberian warming cases, because this is where we're heading. This is what we're in right now, right? This sudden stratospheric warming event is a Siberian sparked warming event. You don't really see this prolonged blocking event over the North Atlantic and Greenland, but instead you see a lot of these periodic changing positive negative signatures over the Greenland area. And what this is, it's essentially these are Rossby waves. We call them Brandstater-Kirchner after the scientists who discovered them, but they're essentially these westward propagating waves in the extratropics that essentially bring these periods of blocking over Greenland, and then essentially that Greenland block breaks down, you get a cyclone there, and then the block comes back. You get a lot of changing patterns, variability over Greenland, with emphasis on these ridges that are really strong there. So while I'm excited for the Pacific pattern to change, it doesn't necessarily mean that we're going to move into a significant negative NAO blocking state that stays there all the time. We're going to see it, kind of emerge and then go away and then come back and go away again. And that's because we're getting these Rossby waves, these Brandstater-Kirchner Rossby waves really start to kind of highlight variability out in this part of the world. And you can actually see it over Siberia and Eurasia as well. This is really changeable weather. So if you're hoping for consistent cold weather over Europe, I don't know if this is the Siberian type of warming you want to see, right? You want more of these North Atlantic warming events. But still, there's going to be these periodic blocking episodes over the North Atlantic, and that's exciting because it's going to bring some cold air down. You're going to get some snow, and for the eastern U.S. as well. You're going to get, whenever you get these North Atlantic blocks pop up, you're going to get some wintry weather, some storm risk across the eastern seaboard. And we're looking at that now in the upcoming forecast. So I'm going to switch off of this PowerPoint here. I kind of nailed what I want to talk about with this PowerPoint and go back to my screen share on Chrome here and look at essentially what's happening in the 500 millibar geopotential height anomaly field that we just kind of talked about here. And to kind of orient you guys here again, time is going down the y-axis. On the x-axis here is your longitude. So 180 degrees is right over the North Pacific. 60 degrees west here is essentially right over Greenland. And you can see right now that there's that big signature for blocking over Greenland, right? In the medium range forecast. I mean, you can see how it's been there for, since early December as well. But note the actual skew in the contours here, right? We're seeing essentially, if you bring your eyes down with time, there's like this a right to left skew in the contours, which is essentially indicating that we're seeing one of these Brandstater-Kirchner Rossby waves start to shape up here. And you can see it over the North Pacific as well, right? Here's that big Aleutian cyclone. Here's that big negative geopotential height anomaly field or signature, and you bring your eyes right over Alaska. There it is, and then it starts to shift out towards Siberia, and here's the ridge starting to make its way towards North America. And I think what's going to happen here, guys, is we're going to start to see this ridge start to pop over the North Pacific here as we move into the second half of January, which is going to bring us some wintry weather. So I think, again, while I'm excited for winter prospects, we're going to see a lot more variability in the pattern over Greenland. And this is going to bring episodes of storminess for the eastern U.S. It's going to bring episodes of storminess for parts of Europe. But I don't think it's a prolonged cold spell for Europe. But I do like the prospects for North America in the sense of maybe getting some more of a pattern change over the North Pacific that maybe stays there for some period of time. And if you look at some of the subseasonal models now, right, I'm going to bring up the ECMWF weekly model. Now, as I just want to put a disclaimer here, right? These models there's low skill as you move out further and further in time. Right now we're seeing, this is the week 2 forecast, and here's that big Alaskan cyclone. Here's the ridge that extends from North America across Eurasia and parts of Greenland. This is essentially this preconditioned pattern that is going to favor the Siberian major warming event. Take a look at what happens as we move forward in time. So this is week 3. That you see the biggest feature here over the Hudson Bay and parts of Greenland. The problem with this axis right now, where this ridge is it's too far south to really allow for some cold air to get across the eastern northeastern I-95 corridor. This is essentially a very mild pattern for the North America, and that's because we still have this cyclone out over the North Pacific that's bringing in the Pacific jet. This kind of looks like an El Nino pattern, modified in a sense for a weaker El Nino, but it's still not like you typically expect during La Nina winters. But that changes. As we move into the second half of January, we kind of see the pattern shift where we get more of this ridging feature out over the North Pacific, and we see the blocking feature kind of over the North Pole and Greenland, and we get this area of below normal heights that extends across North America, central U.S., Western Canada, and into the eastern, northeastern U.S. This is a pattern that a lot of winter weenies out there want to see for some cold and snowy weather, right? We all like to see that. And this is essentially being highlighted in the models here. So, this is now the second half of January into early February that we're looking at maybe 2 to 3 weeks after our sudden stratospheric warming event happens. It's essentially an encouraging signature for folks who want some change in the pattern. And that's what I'm looking at right now in this model. Now, obviously, these models are going to struggle, but the good news is this model is being initialized. It's seeing the sudden stratospheric warming event in the model. And that's good news because you're not going to have a significant curveball here in the forecast. Like if it didn't see the forecast, if it wasn't predicting a major sudden stratospheric warming event. And we see that, we've seen that in our models before, where, the February 2018 case was a great example where all models were showing a really strong positive NAO and, in weeks 4 and 5. And then in week 3, it started seeing the sudden stratospheric warming event and it completely flipped the forecast pattern. I actually had some slides in my PowerPoint presentation that I gave at AMS, and that PowerPoint that I just showed you, if you guys want to go back to that and watch that presentation. So anyway, this is encouraging signature for me, at least, to see some possible shift in the pattern over the North Pacific. We're still looking like patterns going to be blocked over the North Pole, and I do have a feeling here that we're going to see the models start to split the vortex into sister vortices here, probably about maybe in a week, or actually the next 3 to 5 days. I think we'll start to see some GFS members start to split that out as we look out in the hour 360 to 384 time range. So there's some exciting things on the horizon there. I do want to talk about some other interesting things here that I'm going to actually back out here and go into some more complex zonal momentum transfers. So I showed this here on one of my tweets, guys, where we were looking at zonal wind anomalies on a latitude by time axis. So if you look at this y-axis here, this 0 line is essentially the equator. And anything north of that is your northern hemisphere. Anything south of that is your southern hemisphere. And for a lot of November, when we had a strong polar vortex, we saw a lot of anomalous westerly flow at 10 millibars, which is the stratosphere, which is when you have a strong stratosphere polar vortex, you're going to see strong westerly flow at 10 millibars in the northern hemisphere extratropical belt. It's just normal. However, now when we're starting to see our sudden stratospheric warming event take place, we're seeing those anomalous westerlies change to very strong anomalous easterly winds. This is that significant deceleration of the westerly wind belt around the North Pole, and essentially your reversal of your westerlies to easterlies that corresponds with your major sudden stratospheric warming events. So I want to show you guys something here that's pretty interesting because actually I want to see if this is refreshed here, if we have the 12Z data in. Of course it was not. All right. Okay, we'll just stick with this here. So as I go, I'm gonna start at the top of the stratosphere and make my way down level by level and go from the 10 millibar to the 20 millibar to the 30 millibar, etc. And I want you to keep an eye on this big area of anomalous easterly flows from the 60 to 90 belt range. As we get lower and lower into the stratosphere and down towards the top of the troposphere here, you can actually see how there's essentially easterly flow all the way to the top of the troposphere, and you can actually see that flow coupled down into the lower parts of the atmosphere. Take a look at all the essentially there's some kind of tilt there, but there still is this deacceleration of those mean easterly flows down into the lower part of the troposphere here where we live. And essentially this is an indication here that even though we haven't seen a stratosphere warming yet, there's going to be this significant, or a stratosphere split of the vortex. There still is some coupling between the stratosphere and the troposphere. And that's something that we typically don't really talk about much because we don't really look at the weather in this type of framework. Now, there is something else that I want to kind of talk about here, which I think is pretty interesting, and I'm still kind of learning about these momentum fluxes. Back in November, this is November 8th through 13th here, we had this anomalous easterly feature right around the equator, around 500 millibars. And as you move forward in time, we can see this easterly feature propagate poleward with time. And this is what we're calling a poleward surge of easterly momentum. And it essentially seems to have gotten to the North Pole, right? You can kind of see it at the 250 millibar level. It got to the North Pole right around December 18th, December 23rd, and it's been there since. And it seems to be a precursor to what was this major sudden stratospheric warming event. So I'm not really sure essentially what this feature is or how it's behaving, but there seems to be some possible long-range predictability component here that I think that this is a hidden piece of the puzzle here to understand how to predict these major sudden stratospheric warming events. And we could have gone back into maybe November to start to say, hey, there's a possible risk here for an easterly surge of momentum all the way to the pole. That splits the vortex. So who knows? This is just something that I thought was interesting, but it's nevertheless there, something I wanted to point out and talk about just a little bit. So let's move on to another image here and talk about impacts for the winter here. I'm getting close to the end of our stratosphere discussion, and I can move into essentially some ENSO discussion here for a little while, but I wanted to talk about something here that is provided by meteorologist Simon Lee on his website. Fantastic meteorologist to follow on social media, guys. He's done some work here in the GFS ensembles, the new 35-day, and taking a look at some of the North American regimes. And you can see each regime has a different box to it, where the red regime, this pink regime, is an Arctic high, the blue is an Arctic low, the yellow is an Alaskan ridge, and the green is Pacific trough. And time is on your x-axis here, and your percent of ensemble members is on your y-axis. So wherever you see these big green bars, it's essentially saying that the atmosphere is essentially favoring a Pacific trough regime. And whenever you get a Pacific trough regime, it's hard to get cold air across North America. Well, it does look, this is right around the time of our stratosphere warming event. And then take a look at what happens, right? You see the green bars start to go away as you get out into the second half of January. There's still a risk for the Pacific trough to be there. But one thing that's new now is we're starting to see more orange bars pop up. And that's essentially an indication of your Alaskan ridge. And, I talked about after our Siberian sudden stratospheric warming events, you typically see a transition in the North Pacific pattern to one that favors more Alaskan ridging. And that's what brings in your cold air for North America. Well, we're seeing that in these ensemble numbers, right? We're starting to see these more, we're actually seeing some of the transition here from the Arctic high to the Alaskan ridge. So this is an indication here, the second half of January into the front half of February is where we could start to see a transition in the North Pacific pattern, which could bring some colder temperatures for North America. So I just wanted to focus on that. It's the hope for change in 2021, guys, for some wintry weather. Okay, I want to move on here and change gears and talk about some tropics here and look at our ENSO La Nina event going on and finish up our discussion here because I'm getting close to an hour of discussion here, and I want to look through some of the chat before we end this and answer any of your questions here. So you guys have any questions and want to post them in the chat, I'll get to that here shortly. Taking a look at sea surface temperature anomalies here, wherever you see the warm colored shading, it's warmer than average temperatures in the oceans. You ever see the blues and darker blues? That's cold anomalies in the ocean. And here's our big Pacific La Nina signature here. You see essentially cold anomalies extending from the Peruvian coast all the way out to the date line here. And this is a classic La Nina signature. And as we move into, more of our standard matrices to look at how ENSO is behaving, this is our ENSO 3.4 index, and you can see temperatures have been hovering between -1 to -1.5 degrees Celsius below normal, which is robust La Nina territory. What I like to do, guys, when I take a look at ENSO, I really like to look how the atmosphere is coupled, and that's through these low frequency filtered type of diagnostics here. And typically what I look at is essentially when the atmosphere couples to the ocean variability, where does the atmosphere continuously rise and where is it continuously sinking? And that's done through low frequency filtering, 200 millibar velocity potential. Essentially, wherever you see the purple and blue shading, you can think of it as air diverging aloft or rising out of the page. And wherever you see like these yellow and red, you can think of it as air sinking. So you have a large area of ascent over the eastern Indian Ocean and part of the maritime continent. This is kind of like analogous to like your La Nina skew to the pattern. One thing that's interesting is when you do get a lot of Indian Ocean forcing for ascent at lower frequencies, you tend to see more blocking events over Greenland. I didn't show that, but I have shown that in previous presentations. So I think that's interesting tidbit there. But this is like a La Nina forcing. Your atmosphere is starting to really couple to La Nina here in the signature. And I like to look at these time longitude plots of low frequency filtered velocity potential to really kind of understand what has happened here over the course of the year and a half. And if we look at last winter, right here at the top of the image, this is December 2019 and then January 2020 at the top here. And if you look at the blue shading here, we had essentially a force area of rising air right over the date line. This is kind of similar to your Modoki event. But we also had an area of rising air over the Indian Ocean. And as we moved into spring and summer of this past year, we saw a complete reversal of the forcing over the Central Pacific, and we saw essentially, instead of rising air, we saw sinking air. And this was right around the time of the hurricane season. This is a really big signature for a very active hurricane season. This is one of the reasons why I was so bullish in my calls for the hurricane season this past year, because I noticed that the atmosphere was showing more of a La Nina forcing signature over the Pacific. But more importantly, we had this essentially area of big rising air over Africa and our Indian Ocean. And this is the type of low frequency signature that is not common for the summertime. And this is a signature that favors for big MJO events across Africa and the Indian Ocean, which are some of the most preferable atmospheric states for hurricane activity. So now I want to move into winter now, fall into winter. Take a look at how this African standing wave is shut down, and it's shifted eastward towards more of the maritime continent and Eastern Indian Ocean. So this is a pattern that essentially does favor for more of a blocked up type of regime from the North Pacific up into Greenland. We're seeing our atmosphere couple here to more of a canonical La Nina from what was not a canonical La Nina this summer. So we're seeing the atmosphere start to adjust to more of that behavior. Now, if we take a look at our 20-degree isotherm depth anomalies, essentially looking at the thermocline and specifically the 20 degrees Celsius level and seeing what's above where it normally lives in the Pacific Ocean. This is a really good field to track oceanic Kelvin waves. So you can see, like, when you get a positive oceanic Kelvin wave, you can kind of see it brings some warm water from the western Central Pacific all the way to the eastern Pacific. But you get downwelling oceanic Kelvin wave, or upwelling oceanic Kelvin waves, which are associated with a deeper thermocline, and it brings cold water or upwelling from the Pacific, all the western Pacific towards the eastern Pacific. And if we look at the most current time here, right, this was April 2020, and this was the onset of our La Nina signature of the Pacific Ocean. You could trace it from the West Pac all the way to the East Pac. This is typical La Nina ENSO behavior. Now we take a look at what's happening September, October, November, December. There's been a stationary signature here. So we're not seeing oceanic Kelvin wave activity anymore, and this is an indication that our atmosphere, or that the ocean is found a somewhat of an equilibrium state where it likes to stay in this La Nina state. There's no momentum inertia to kick it out. Now, what typically happens to get us out of this La Nina state is we'll see the West Pacific warm pool start to grow and build, and we'll start to see some, maybe some significant MJO activity over the Western Pacific, or you could think of it as like sometimes you get into like the winter spring season, you get like these twin cyclones over the northern and southern hemisphere. Like you have a Westpac typhoon and a southwest Pacific cyclone there. Those can force these things called westerly wind bursts that can then eventually push a response in the ocean, develop an oceanic Kelvin wave, and get that warm pool from the Westpac over the Eastpac and start an El Nino cycle. But we're looking way beyond this. I don't think this is going to happen anytime soon. It might not even happen next spring. We could actually see another La Nina moving forward here into essentially the summer of 2021. And that could result in another active hurricane season. I don't want to say anything yet because I don't know if it's going to happen, but from some of the model guidance that I've seen so far, the tropics looks very similar. The predicted state of the tropics for summer 2021 looks very similar to what we just saw this past summer. And if that is true, if those models forecast hold true, we're going to have another active hurricane season for next summer. So we'll see it there. I'm not trying to hype things. I'm just telling you what I'm looking at the models here. And obviously there's low skill as you get out that far. But there are some things there that are encouraging at least for more Indian Ocean forcing into summertime and essentially suppression or Pacific suppression that could cause a lot more weather conditions for Africa. Africa always needs wet weather, guys. But unfortunately, it does result in more of hurricanes spinning up for us here over the North Atlantic basin that could impact the U.S. again. And it was just a historical hurricane season. All right, guys. If you have any questions here, put them in the chat. I'm going to start to read through here and see if there's any questions here because I wasn't able to kind of focus on them yet. But I do want to say if there are any aspiring meteorologists out there, that are watching the stream or come back and watch this, guys, one really hot topic is understanding these stratosphere warming events and how they impact weather and bring extreme swings in circulation across the entire hemisphere. And also, just from my experience, there's a connection between the tropics and the stratosphere, guys. You think about these sudden stratospheric warming events, right? You get a lot of warming over the North Pole, but you get cooling along the equatorial belt. And what that does is it enhances the Brewer-Dobson circulation that can really help enhance your tropical convection state. So there is a connection there that I'm really interested in kind of understanding. And I really hope that some future bright meteorologists out there will kind of, look at this bit more and find some really interesting relationships and help us understand how our climate system works better, because it's really, really interesting here how these things work. So, all right, I'm going to start answering some question here, guys. I do see an old question in the chat from AP 1180. Do we know what is causing these acute warming events above Siberia, or are they just naturally part of the cycle in the stratosphere atmospheric circulation? So, you can get these sudden stratospheric warming events starting at any point over the globe. It seems like there's preferable locations. Siberia is one of the preferable locations, but so is the North Atlantic. And this particular event was sparked, in my opinion, from this big Aleutian cyclone that has been just dominating much of the December pattern, and it's going to continue here through the end of the year. And that is helping provide this upward wave flux that eventually disrupts the stratosphere polar vortex. We see these a lot. We typically see these types of events more in El Nino type of atmospheres, which is kind of peculiar because we're in a La Nina state. We've seen a lot of the oceans in La Nina. The tropical forcing state is adjusting more towards the La Nina, but it's not perfect. There's still some Indian Ocean forcing there. But they do happen. They are common. I see a next question here, Fish and the Hunt Guy. Do you think the Pacific Northwest gets cold, as often happens in a La Nina winter? get any of the cold later in January from the vortex. I know the Pacific jet is just so strong right now. I think I covered that pretty well, guys. And just to reiterate that point, yes, I do think we're going to see a significant pattern change over the North Pacific. We're going to see the Pacific cyclone, that Aleutian trough, go away, and we're going to start to see a ridge start to develop over the Aleutian cyclones. And I think that's going to happen probably sometime in the second half of January. So Leo Gamer 5000, where is the cold going to go with this major sudden stratospheric warming event? Guys, this is the beauty of meteorology. We don't have all the answers here. So I don't know. I'm not really sure exactly where the cold is. I think that the west, I would say Western Canada is probably going to start to develop a pretty good cold pool here as the North back jet starts to break down, and we start to see a ridge develop over the North Pacific. I do think Europe will see some cold waves here. Probably Scandinavia and Russia will see the brunt of it. But again, there's going to be like these different variations of the pattern that I just can't tell right now. But I do like the idea that there will be some wintry weather risks here for the eastern seaboard as we move into the second half of January, potentially continuing through parts of early February. But as that North Pacific ridge gets going, what's going to happen here is the southeastern U.S. ridge is going to want to try to build. Now, if we still have blocking over Greenland, that southeast ridge will be suppressed. But if the blocking over Greenland goes away, we'll have these episodes of southeast ridge flexes, which could bring periods of really extreme warmth up the eastern seaboard. So those are things that we still don't understand, and we're still waiting on to see how it evolves. So yeah. I got a question here from Alex879 wrote, do you consider that the number of events is bigger in Siberia because of the Siberian high? That's a good question. I have not really just looked into why we see more events over sudden stratospheric events over Siberia versus anywhere else in the planet. It's open for research, and if anyone wants to do some collaboration on why, I can help provide some of the data. If you guys want to dive in and get your hands dirty, and we can work on something together there. I got a question here from AP1180. Do years with large volcanic eruptions correspond with abnormal disruptions to warming events, polar vortices in the stratosphere? Thinking about albedo effects and how the Kahlua has been recently. I don't know. I don't think so. One thing that we do see with these large volcanic eruptions, they have to be really significant, and they have to be near the equator to have some sort of significant impact on essentially changing temperatures across the globe. And we call this global dimming. Essentially, we saw this some of the historically big volcanic eruptions near the equatorial band, where temperatures for the globe can actually cool for a year, but it's only a temporary cooling, and then essentially the atmosphere readjusts back into what the base state has been. So it's one thing that I can tell you right now. I have not studied volcanic eruptions to kind of connect it to weather variability and especially stratosphere. That's another point that needs to be researched. So, okay, I see another question. Is the solar cycle really important at those layers of the atmosphere? I see that you're an oceanography student. I don't know. That's a good question. I think you hear the solar cycle as an important culprit for blocking over Greenland. We were in a solar min, but we didn't really see much of blocking in that year. I think it was the exact opposite when the polar vortex was extremely strong last year. So I'm not really sure on that question. Space weather and atmospheric weather, there's still a bridge or a gap in our understanding that needs to be bridged. So again, another open area of research. If you want to start to look into space weather and connect it to how weather impacts in the troposphere, there very well could be something there. I'm a strong believer that the stratosphere is a big player on weather here in the troposphere. There's got to be something else forcing it. So maybe there's some connection to this in the solar cycle, but I just don't know. I haven't seen enough evidence really to kind of sway my personal opinion on the solar cycle. But there is some interesting work done by a scientist from NASA called Bob Lehman and some of his co-authors that looked into different states of the solar cycle by pretty much identifying solar spots in the sun. And there's some really cool things. Like during specific states of the solar cycle, there's going to be a lot of sunspots near the equator of the sun. And then as time goes on, those sunspots kind of propagate poleward to the north and south pole of the sun. And that's essentially the end of the solar cycle. So there's some really cool things there that Bob Lehman and some of the scientists there in NASA that they've done that suggest that there could be a connection between solar cycle activity and ENSO. And that's something that is really interesting that I don't know yet. That is still some research that needs to kind of, I think, be panned out. So yeah. I see Leo Game for that. The Siberian warming, does it also favor Eastern North America? I'm not really sure if you mean Eastern America cold, but there probably will be some cold periods when the Greenland block starts to flex on and off here. So yeah, let's keep moving here. Out from Alex879RO, do you consider that the La Nina forcing is a decisive factor in the vortex split? I've seen in 2018 that the vortex rebuilt itself very fast. We had an El Nino forcing back then. Does this change the consequence of stratospheric warming event? The answer is no. Stratospheric warming events can happen in a La Nina regime or an El Nino regime. And I typically what happens when we have a major sudden stratospheric warming event, the stratosphere polar vortex splits, and we see a slow propagating signature from the stratosphere down the troposphere that lasts for a number of months. But the stratosphere polar vortex will rebound. It does come back. We often see a period of intense cooling at the stratosphere level following, like maybe a month or two following these sudden stratospheric warming events and these big warming pulses over the North Pole. So we typically do see the vortex rebound and come back at some point. So that happens, but I'm not sure how ENSO plays a role in that. Again, this is something that I feel there's still a lot of work to be done there in understanding these events. Do you consider that the Southern Oscillation Index is a good method of understanding La Nina coupling? Okay, so this is a hot topic, the SOI index, and whether or not it's a good metric for understanding ENSO and coupling to the atmosphere. So I think with back 20 to 50 years ago, the SOI was probably a reasonably good metric to kind of look at atmospheric coupling and ENSO during specific ENSO states. But I want to be clear here. ENSO is a spectrum. There are so many different variations of ENSO that a particular index looking at two different points, one over Darwin and one over Tahiti, it's not going to capture the atmospheric coupling component to ENSO. So if you really want to see how ENSO is behaving in the atmosphere, I strongly recommend applying some kind of low pass filter on a 200 millibar wind field, like you can look at zonal wind anomalies, or even I really like velocity potential anomalies, and that will show you the spectrum of how the atmosphere is coupling for these different variations of ENSO. So I am not a strong user of the SOI. I do believe that there are cases where it is useful, but I do also feel that there's so many different variations of ENSO. You really need to look away from point indices, especially those of the Southern Hemisphere, and start to understand more of like a look at the different latitudes and longitudes to get an understanding of how ENSO is behaving and how our atmosphere is coupling, because it does vary case to case. And by looking at just 2 points in the Southern Hemisphere, you're never going to see that full spectrum. And this is one thing that drives me nuts about essentially our ENSO3, how we identify El Nino or La Nina in ocean temperatures, looking at like a 3.4 index. We're missing a ton of events there. The atmosphere is, if the ENSO 3.4 is neutral, we could see a really significant forcing signature over the Western Pacific that is getting ignored. Everyone's like, oh, we're in ENSO neutral state. Well, no, the atmosphere is coupled to something going on in the Western Pacific. So we're just throwing that information out. No, we got to go back to the drawing board to how we identify ENSO. And we really, if you want to use ENSO to understand predictability in S2S timescales, I really recommend taking a look at some like wind field, like 200 millibar velocity potential or such, and see how look at the anomalies, apply some low pass filter on there, and then you can really see the variations year to year, because it changes year to year. Okay, moving forward here. Hey, Iowan, thanks for joining, bud. Appreciate it. Why do I have to follow you to chat? Well, that's because I put a filter on my Twitch here to build up my following. The more followers, the more viewers I get, the more I can do these types of things and spend resources to enhance my technology to be able to make these a better place here. I do stream Call of Duty as well, and I do stream these weather briefings time to time. You can actually subscribe if you guys are Amazon Prime members. You can actually hit the subscribe button and gift me a free subscription, and I use all that information to help build up my resources here to make these streams as smooth as possible. So thanks guys for everyone who has subscribed, and I appreciate those that provided that, because I continuously updated my tech here moving forward. So Port One Drinker, thanks man for joining the stream, appreciate it. When do you think we'll be able to be confident regarding the ensuing North America cooldown? What will you be looking for? All right, guys. So I'm looking for the North Pacific pattern specifically. I want to see that Aleutian cyclone breakdown, and I want to see a North Pacific ridge. And it all comes down to the North Pacific jet. In order to get some really significant Arctic cold airs across North America, you need to see that North Pacific jet turn into a weakened state. And I think we're going to get there, right? I think it's going to be some point in the second half of January or maybe early February where we start to see that Aleutian cyclone breakdown and we start to see more of a North Pacific ridge. And I do feel like it's going to be the second half of January. So I'll be looking at the extended range models. I think I'm kind of leaning on the week 4, week 5 for that to be happening. But, 4 or 5 weeks from now, so I guess that is the second half of January. But I do think that's the one thing that I'll be looking for, is that North Pacific ridge starting to pop up. Alex879RO, I heard that the interaction of the vortex with the equator is influencing the polar vortex type during the winter, being a factor for a strong vortex. I'm trying to understand the question here. So I heard the interaction of the vortex with the equator is influencing the polar vortex type during the winter. So I think that we're still kind of understanding how equatorial circulations and the polar vortex really impact are connected. And I showed that momentum surge plot where we had an easterly momentum surge at the equator back in November that propagated poleward towards the North Pole, and it seems to have preceded this major sudden stratospheric warming event, which I say major, it's still a forecast, so we're not sure if it's going to happen yet, but so I think there's something there. We get these momentum fluxes from the equator to the North Pole all the time. Sometimes you get these westerly momentum surges that kind of propagate from the equator towards the North Pole, and those are really interesting because once that westerly momentum surge is near 30 degrees north, it accelerates our subtropical jets in the Pacific and Atlantic. And then as it moves into the 60 north, that's where we see these extensions of the Pacific jet and North Atlantic jet. So there's these interactions that happen all the time, but I don't really know anyone who's done the research to kind of look at those oscillations and momentum surges from the equator to the North Pole and how they interact with or ignite these sudden stratospheric warming events. There is so much left open in meteorology, guys, to kind of go out and understand those things that I think we're probably a good 5 to 10 years away from understanding that completely. And we need we need smart scientists to get in there and really start to look at them. Okay, a question from the Shrekinator. Dude, I like your name, man. Thanks for that. Guidance shows that the Pacific is improving over the next 2 weeks. Does that make sense to you or not? It does, because I think the models are seeing the sudden stratospheric warming event, and I think that we're starting from what I've seen, my research, when you get those Siberian warming events, one of the biggest changes in the pattern is the North Pacific pattern. And that's where we see this major Aleutian cyclone, what we're seeing now, and we're seeing in the forecast here next week, that changes, that breaks, that goes down, and we get a ridge that replaces it. And essentially what that's indicating is your Pacific jet is breaking down. And instead of having this fire hose Pacific jet that's bringing that warm, mild Pacific air across North America, we turn that off when we get the Arctic jet that comes down out of Canada, out of the Arctic Circle, and that brings some cold air. So I do believe that these models are starting to see that, and I think that we can believe that. But the timing when that happens, it's still unclear. Another question from the Shrekinator. Is it impossible to know where the lobes of the cold air will end up going before the vortex disrupts or splits? So, long time scales, yes. It's impossible. And if someone's doing a seasonal forecast and they're going to say, yo, there's going to be a sudden stratospheric warming event that splits the polar vortex, I'll tell you right now, we have no clue where those sister vortices end up going. It's essentially like trying to predict eddies in a chaotic system. But that being said, as you get closer in time to the reality of the event verifying, like we're kind of getting to now, right? Look at hour 380, 384 of the GFS. I know it sounds crazy to say, hey, how can you believe an hour 360 GFS operational model? Well, you can't believe it when it comes to like storms, right? Low pressure, high pressure systems, but it does a pretty good job of predicting stratosphere that far out. For whatever reason, we have more predictability when it comes to like higher levels of the atmosphere than we do at lower levels of the atmosphere. So we could start to believe maybe with some hesitation where these vortices are going to spin up. It looks like one's going to be over the North Pacific and another one's going to be over Siberia. But again, it's still a little bit too far. But as we get maybe a week from now, I'll start to look at those model runs and feel a lot more confident when those vortices are going to go. Okay, so, Captain Potato, thanks for joining, man. I appreciate you always coming back to the stream supporting here. I'm looking forward to your severe thunderstorm index for spring. I've always liked those two. Hey, I appreciate that. Those severe thunderstorm indices, that's something that I'm trying. There's some discussion here with some of the consumer app guys, the Weather Channel app on your phone and your weather.com, that maybe we can integrate some of my nerdy products on there so you guys can see some maybe severe weather forecasts out the next 10 days. But that's still a long ways away to really kind of put that out there. So, but there's some discussion out there. I'll make sure to continue to post those on social media for some of the big events that I identify. But thanks for that. Okay, so another question. Alex, you love the questions, bro. I appreciate that. Did you ever have the opportunity to look a bit over the intensity of these vortices, like last year's that brought very intense vortices? Do you consider global warming as a factor in those types of vortices? I have not been able to really look into the climatological aspect of how strong vortices are. And do I think global warming is a factor in those types of vortices? Probably. We've typically seen throughout time, essentially global warming has been shifting more in the sense of skewing the intensity of ridges across the extratropics and kind of diminishing the amplitude of troughs. But I mean, it varies case to case. I'm just kind of looking at long-term statistics. But I can tell you this right now, global warming will not dictate a single trough amplitude, right? Look at one trough and be like, oh, this is a very strong trough. You can't dictate global warming to that alone. You need to see a number, like a very high sample of troughs or ridges to really attribute climate change as a contributing factor to why the amplitude is changing or not. So, Post Drinker, could you post a link to your Beasts of the East presentation? Sure thing. I have a link of that on my webpage. I'll put that on here on my Twitter right at the end here. So, without that, I don't see any more questions. I tried to answer everyone. So, guys, thanks so much for joining on the stream today. I appreciate it. I hope you guys learned something today, and I hope what I wanted here. The goal was for you to start thinking about these things a bit more, looking at this in a different light. You can't just look at a sudden stratospheric warming event and say, hey, it means this. It means it's going to be cold. It means it's going to be warm here. We don't have that type of understanding yet. It's still a new thing, and we're still trying to understand this as scientists, okay? I'm really hoping that, through some of these presentations, guys, that any aspiring meteorologists out there, they start to do some research here and start to look at some of this stuff, because it's really fascinating. I think it's really interesting. If I was back in grad school, guys, I would be all over the stratosphere and how it couples with troposphere and how it relates to the tropic, because there's so many cool different things there. I'm telling you this right now, guys. I've said it to some of my clients. Stratosphere variability really plays a role, and even that, for that matter, like equatorial winds in the stratosphere. there's a connection in the tropics, and there's a big player on MJO activity. And I studied MJO in grad school and how it influenced hurricane activity, but I couldn't tell you why I'm seeing more years or less years with MJO, big MJO activity. I know that particular ENSO states, when there's strong coupling in the atmosphere, it really kind of stunts your MJO activity. But there's something to it with the stratosphere here. So I really, really hope that you guys out there watching, someone out there, can help us discover some new cool science, and really help us understand our climate system there, because there's something there, guys. All right, guys, I appreciate everyone joining today. It's December 30th. We're a couple of days away from the end of the year, the end of 2020 and the beginning of 2021. I really hope and wish you all the best in the upcoming year here, guys. Happy New Year, happy holidays, and please feel free to join in a Call of Duty stream here when I get going here at some point in the near-term future. All right, guys, take care. God bless. I'll see you soon.